permutations order mattered. So license plates, codes, telephone numbers. If I picked a group of people from another group of people and I gave those people jobs, right? Or I picked a group of people from another group of people and I gave them presents and all the presents were different, right? Because then order would matter. Or I gave them a trip and all the trips were different, so order would matter, right? If the people that I'm choosing from the group changes their outcome in the order I picked them, it's a permutation, right? That we talked about that. Today we're talking about combinations. So discuss how throwing 3 toys in a bag is different than lining them up. So if I went and I had my 3 toys and I took them and I just tossed them in my bag, how many ways can I do that? 1. I literally just pick up my 3 toys. Here they are. These are the crappiest toys ever. The 3 yellow highlighters. This would be the worst toy. Actually, they all match, so that's going to cause a conundrum. You're like, there's repetition. No, there's not. They're all different. Look, I have 3 colored heads. I take them. I do this. They're in my bag. How many ways does that happen? 1. Okay, cool. Did the order matter which I threw them in my bag? No, I threw them in. Whoa. Get that later. So I just threw them in my bag, right? And then my bag sucked and they all fell off my table because my table bag is really bad. Table bag is not a bag. Anyways. Okay, so if I put them in like that one way, right? Because it's a combination, order didn't matter. Order didn't matter. Oh, English didn't matter either. All right, so order doesn't matter. So we have 3 objects. Come on, join me. We have 3 objects. And we decided this was a combination, right? We said the order didn't matter. So doesn't matter. I did it again. And we choose 3 objects. So it's going to be a C because it's a combination. We're also going to be able to use P's as well, but the problem with permutations with a P is that the only way you can use it is if you can't repeat and all this jazz. So that's why we use the fundamental counting principle more than the P. But this one we do 3C3. So go to your calculator where I told you where we're going to live, which is the probability button. So we're going to press 3. So you're going to press 3, math, probability, then which number?
3.
3. Okay. So we're going to go 3, math to probability, and we pick NCR because it's combination. So this means we have 3 items, and we choose all 3 of them to put in the bag. Poof, one way, right? We have all 3, we throw them in. So that's 3C3. Yeah?
How is the C different than the division sign? Or I have another amount I see the formula together.
Yeah, there's quite a difference.
There's quite a difference.
There is a division sign between the 2.
Yes.
This is true. There's just more things and stuff. Yeah.
A lot more stuff.
A lot more things and stuff. Okay. Now, how is that different than lining them up? How is that different than lining up the toys? I take them, I throw them in the bag. Done. One way. I'm going to line them up. What should I do if I'm lining up stuff so I can visualize it? The fundamental counting principle. Because the fundamental counting principle literally shows you lining them up, right? I have a blank, this blank I can put X in. This blank I can put X in. So the moment you're lining something up or arranging it, you can use the fundamental counting principle because you literally can visualize you lining it up. If you're not lining up something, you cannot use the fundamental counting principle. So some people try and do it with combinations. So the first blank I have how many toy options? 3. I leave. Then the next one. Leave 1, then the next one. So I told you we can do the fundamental counting principle. We could do this. So I would have 3 options for this one, 2, then 1. Now, what I wanted to explain is if you started a number and go down by 1 each time, you can use the P. You can use permutations. But you have to go down by 1 each time. So if I could repeat options, let's say, and I had this, I had 3, 3, 3. I can't use the little P letter. I can't use the permutation letter. If there's repetition, I can't. Okay, so like when we did the license plates and we had 2610, 2610, 2610, can't use the P. I can only use the P if I go down by 1 each time. So this one here would be 3, I have 3 objects and I pick 3, correct? Type that in, 3T3. What do we get?
6.
Which matches this, right? 3, 2, 1 is 6. Now some people will say, okay, cool, I could put 3 factorial as well. Yes, you could. That's if you're choosing all the objects. Let's say I had 20 toys and I was arranging 3 of them. Remember, if it's arranging, it's a permutation. You hear the word arrange, I'm ordering them, I'm lining them up, you're giving them order, it's a permutation. If I had 20 toys and I was arranging 3 of them, let's say, that would mean I would have my 3 blanks, right? And I have 20, and I'd have 19, and I'd have 18, and I'm going down by 1 each time, correct? How can I represent that with a P? Well, I have 20 toys. I'm arranging. That P you could literally use interchangeably with the word arranging, because permutations are arranging things. I'm arranging how many? 3. So these are actually the same. I'm arranging 3 without repetition. I can't repeat the same toy. The moment you're arranging toys, lining them up, you have to leave one behind, right? So that's how you could use the P letter. Could I just use blanks? Absolutely. Could they on a test give you a numeric response where they say A, P, B, the value of A, P, are what? And then you have to put a numeric response box? Yeah, and if you only know a fundamental accounting principle, you can't use the P. So you do have to know everything, because depending on how they ask a numeric response box. They'll say A, B, respectively, and then you have to put them in order. So then that would be 20 and 3. So I go 2, 0, 3 in the numeric response box. Like if they said A, P, B, the value of A and B respectively, you'd say 2, 0, 3. Because respectively just means in that order. So they can ask things like that. So that's why we have to know lines and we have to know P's. Some people are like, well, I've got fundamental accounting principle, I'm golden. You are if they don't ask you it in a P. You are golden. All right. In general, the combination formula, which is given on your formula sheet, which I self-print, is NCR equals n factorial over n minus r factorial. The difference between the NPR and the NCR is this little r down here. That r factorial doesn't exist in the NPR. Does anyone have any idea why they would have an r factorial in the bottom of the C one, which doesn't have any, which order doesn't matter, and the P one doesn't have that r? What does a factorial in the denominator do? What have we learned? When have we used a factorial in the denominator? Yeah.
When we're getting rid of repeats.
When we get rid of repeats. When we get rid of cases that are not different, right? Like mammals, when the A's just swap and we know that they're not different, right? So we put factorials in the bottom to get rid of all the places where the cases actually aren't different. So cases happen when order matters. When order doesn't matter, we don't have cases, right? So we're going to divide by this r factorial, however many there are, because that's going to get rid of the places where we would say order matters, right? It gets rid of the cases where there actually order doesn't matter. So like if I went and lined up these 3 toys, and I went like this, 3 times 2 times 1, I'm giving it order, correct? But if I divide by, so this would be 3C3, correct? But if I divide by the 3, it gets rid of all the cases where they actually are the same, because we're taking them and we're throwing them in a bag. So that's why this one has the r factorial in it. It gets rid of all those cases, because you don't have cases, because order does not matter in a C. That's why the formula has an r on the bottom. Now, the only way to calculate a combination where order doesn't matter is using the formula, and then I showed you that, or actually using the formula or the calculator. Now, this one here, there's a catch with C's. It doesn't work with P's. So for example, with the C, 10C6 equals 10C4 in your calculator. 10C6, type it in, and 10C4, type it in. NC6, 10C4. So you can go 10, math. So we get 2/10 of both, correct? Same answer. Okay, do it with p's. Do 10p6, 10p4. Are they the same? Remember, 10, they're not, because 10c6 means I have 10 objects and I'm arranging 6 of them, correct? 1, 2, 3, 4, 5, 6, 10, 9, 8, 7, 6, 5. These are the same. This means I have 10 objects and I'm arranging 4. 10, 9, 8, 7. Would those be the same mathematically? No. So that's why it doesn't work with P. Why the heck does it work with C? Let's go back. Let's use the Z formula. So I'm going to use the formula below each of them. I'm going to do 10C6 first. Go away. So the formula is NCR is n factorial, so our n is 10, and then the r's are 6, right? I'm going to erase this because it doesn't look like there's a factorial. So I'm going to go 10 factorial over 10 minus 6 factorial, 6 factorial, because that's what my r's are. And then I get 10 factorial over 10 minus 6 is 4 factorial, 6 factorial. And I'm going to leave it there. I'm not going to turn it into an answer. So I just filled in the n's and the r's. Does it make sense what I did, how I filled in the n's and the r's? Now we're going to try it on the next one. The r just happens to be 4 this time, right? I would have 10 factorial over 10 minus 4 factorial, 4 factorial. So now I'm going to get 10 factorial over 6 factorial, 4 factorial. Does 4 factorial times 6 factorial result in a different answer than 6 factorial times 4 factorial? No, because of the commutative property of mathematics and multiplication. You can flip them. 3 times 2 is the same as 2 times 3, right? So the reason why C's work is because it has that extra r factorial. Now, let's see if you figure out how we can figure out which ones get you the same answer. So what if I gave you 10C2? What would that be the same as? 10C what? 8. Why is it 8? Pardon? Yeah, and because you're doing this difference here. If you look here, do you see this difference? It's 10 minus 6. So this blank will always be these two subtracted. This blank will always be those two subtracted, right? So 10C2 is actually the same as 10C8 because it's the difference between the two. These two numbers, your r's, should add up to what your n was in order for them to be equivalent. So if I gave you, let's try another one. Don't shout it out. Just you guys try this one. I want this one shut out. I don't want this one because I want to see if everyone catches the rules. So if I go 20C8, I want you to tell me what this one is going to be on your paper. 20C8 is the same as 20C what? That's what I want you to put on your paper. I've seen people writing it. I just watch your hands write numbers and see if it makes a 12. Does everyone get 12? It's just the common difference between the two, right? So if I went 20 minus 8, I'd get 12. So I put 12 here. Because remember, these two numbers should add up to n. The two r's should be n. So if your answer, say I had 20 toys and I was choosing 5 to throw in a bag. Does order matter? No. So I have 20 toys and I'm choosing 5. That would be the answer you'd want to give, correct? And they say, cool, 20C5 isn't an option. So what option could you put that would result in the same answer? 20C15. Does that make sense compared to the question? No. You're like, well, that's choosing 15 toys. Truthfully, it doesn't make sense for the question, but it actually is the same answer. So you have to know that C can give you 2 answers just because it is the formula with that extra r factorial, right? The other thing on your formula sheet, like I said, I can put it in a little top statement. I totally forgot to do that. Is NCR, and it's only C, can be written with this brackets like this. So instead of them writing, say they chose 5 toys from 20, they could give me 20C15, but they also could have just given me 20 and 5, like this. That means 20C5. Or they could give you 20 and 15, that means 20C15. Why do they have something for a C and not a P? I have no idea. Take it up with the math gods. I have no idea. But they do. It's on the formula sheet. So instead of using a C, they can use brackets. Does that ring a bell? It's on the formula sheet. You just need to know it. NCR can be written in NR in bracket stacked. So if ever you see like a bracket stacked and you forget, look at your formula sheet. It literally tells you, oh, bracket stacked is C. Okay? It's on the formula sheet. All right. So here we have, and when you have restrictions with combinations, that alters what you're choosing from. So here we have 3 students from a class of 10 are to be chosen to go on a school trip. Now, here's where your life gets a little more rough. This is where my life got a lot more rough when I took this in high school. Now you have to check, you have to know if it's a permutation or a combination. Up till now, I've only done permutations basically, right? We've done fundamental accounting principle, we've lined stuff up. But now you have to decide, does order matter or not? So 3 students from a class of 10 are chosen to go on a school trip. Cool, let's imagine this. We have 10 students. We're taking 3, we're putting them on a school trip. That's all that's spoken. They didn't say anything else. So 3 students get to go on a school trip. This is what I didn't understand. I have to think, okay, those 3 students going on a school trip, if I pick them first, second, or third, does it result in anything different from those 3 students going on the school trip? Does it? If I gave them jobs, those 3 students, would it change it? Yes. So the 3 students going on a school trip, first, second, or third, you just get to go on the school trip or you don't, right? So what is it, a permutation or a combination? It's a combination because order doesn't matter. The 3 people in which you pick them gets to go on the school trip. I got like stuck. That what happened. So we would go, how many do we have to choose from? 10, C, how many? 3. Now if they asked you to do it algebraically, could you just type it into your calculator? No, what would we have to do? The formula on your formula sheet. So we'd have to go 10 factorial divided by 10 minus 3 factorial, 3 factorial, and then we do 10 factorial divided by 7 factorial, 3 factorial. We have to show with the math if it says algebraically. You can't just show 10C3. What do we get?
120.
No? 120? Everyone said it together, but a little off, and I was like, And then this would be the same thing, and goodness gracious, 10C3 is 120. With your calculator, both of them will get the same thing. And we're going to flip over. So we're just in our notes package. So we're here. Okay, we're going to talk about the Lotto 649. So the Lotto 649 is called that for a reason. You pick 6 numbers out of 49. Okay? Now, does the order in which they're picked matter? That's the question. So those 6 numbers that we're picking, we have to decide, does the order matter? So for the Lotto 649, they would say the order in which the numbers are picked doesn't matter. It's hard enough to get 6 out of 49, honestly. If you had to also get them in the way that they popped out, no one would win the lottery, because then order would matter. So we're saying those 6 numbers have to just pop up at some point in time. Out of the 6 numbers, they have to match your 6 numbers, but they don't have to match it. Like you didn't have to pick like 49, and then 49 has to come out, and then 1, and then 1 has to come out, and then 6, and then 6 has to come out, and then 8 has to come out. You know what I mean? So if I did this, do not do this. If I go boom, 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 the moment I'm writing those, what am I saying? The moment I'm putting blanks, what am I saying? It's permutation. Does the order matter in this question? No. So if you write lines saying, I'm saying permutation. I'm saying there's 49 options for this first blank, and I have to pick the correct one. Then 48 and 47. So if you know it's a combination, And I get people doing this. So like, it's a combination, Lepp. I'm like, cool. And then they start doing this. I'm like, it's a combination, but you're telling me by putting those lines, it's a permutation. It's exactly what you're doing. It's a combination. It's a permutation. Would you look like an idiot if you're like, Mrs. Lepp, it's a combination? Like, that's what you're doing. The moment you're putting lines, you're saying, I have to have something here. I have to have something in this blank. I have to have something exactly here, right? So if it's a combination, do not start slotting in fundamental accounting principle. Okay? Stop yourself. That's where the error happens. So I have 49. Okay, so here it says Jasper selected the 6 numbers from the birth dates of his family, 3, 7, 9, 11, 20, 29. How many different selections of numbers could he have made if he didn't choose those? So all the different combinations we could have with the lot of 649. So how many options do I have to pick from? 49. And I choose how many? 6. So type that in. 49 C6. Quite large. It's quite large, yeah.
So for one.
Oh, my bad.
Sounds like I just got 14 million out of it.
So 49 C6 is 13,983,816. So you have a 1 in that chance. But remember, that's actually not the chance you have because people can choose the same numbers, right? People can choose the same numbers. So it's actually more than a 1 in that chance, technically. Because people will say, well, if 13,983,816 people bought a ticket, then someone's winning. No. Because 6 people could have bought the exact same ticket, 6 other people could have bought the exact same one. 100 people could have bought the same, right? So it does not mean that if you just went out and bought that, you'd actually have to talk to each other and like converse. 13,983,000 of you and 816 would have to converse and say, I'm picking these 6, you have to pick these 6, and you'd have to come up with all the different combinations of what you could pick, right? Now, what if the lotto was actually, you had to pick the 6 numbers and they had to come out in the same order? Well, it'd be 49P6. And that is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's 1, 0, 0, 6, 8, 3, 4, 7, 5, 2, 0. You have a 1 in that chance. No one's ever winning the lotto. Like that baby is getting real large. Okay? All right.
Non-retirement, one hit and I'm set for life.
True. But in the normal lotto, you do pretty good too. So here, ain't happening. That's what we're saying. So example 3, here it says the athletic council decides to form a subcommittee of 7 council members. We have to decide if it's a combination or permutation. 7 council members. How can I tell if it's a permutation or a combination? What has to happen after the word 7 council members? If each one has a specific job, then it is a. If I'm just picking 7 council members, it is a. So we have to keep reading, right? I'm choosing 7. A subcommittee of 7 council members to look at how funds raised should be spent on sports activities in school. Do those 7 council members have jobs? Are they any different? If I picked first or I picked 7th, is my life any different on this committee? No. So it is a combination. So I know it's a combination. So then I can go right away and put down blanks, right? That's a trick question. No. The moment you put down blanks, it's a permutation. You're ordering them. Okay, here it says there are a total of 15 athletic council members. So if I was just picking a 7-person subcommittee from the 15, I would go 15C3. Or 15C3, where'd the 3 come from? 15C7. That would be if I just was picking 7 council members, correct? But it keeps going. It says there are 15 athletic council members, 9 males, 6 females. The subcommittee must consist of exactly 3 females. So what is that indirectly telling you? If I have to have exactly 3 females, what are they indirectly telling you? I have 4 choices left and they must be male. Now, what I get on the test, how can you guarantee getting a female choosing from a female? So I have 6C3 is what I often get on a test. That's what the answer will be. That's what you guys often give me, 6C3. But remember, this is a what person subcommittee? How many? 7. and you just said 63 is the answer. Trust me, that'll be one of the answers on the test. It's chosen. Because it says exactly 3 females. People are like, cool, I'll choose 3 females and I'm done. However, it is a what person subcommittee? 7. So I need how many? 7. I currently have how many? So I have to keep going, right? I've only chose 3. So I also have to have this. I need the 3 females and, so I need to multiply, 4 males. How many am I choosing from? 9. That's my answer. So do you see how you could oopsie and go 63 and think you're done because you're reading the question and it says exactly 3 females? It's not telling you you need the rest. But it did up top tell you need the rest because I need 7 members. And if I pick 3 females, I only have 3 members.
Maybe I put some brackets in there.
You don't need brackets. You can just type it in the way it is. It will stick those numbers to the C times stick those numbers to the C. So here we have a standard deck of 52 cards. If they give you a card deck, they have to like lay it out for you. It can't just be like a downfall because you don't know cards. Okay? So they have to lay it out for you. If it came to a test and you're like, Mrs. Lepp, I don't know how many clubs there are, I'll tell you. Because you can't have a defect because you were a person who didn't play cards and someone else was like a cardaholic as a child, right? So there are 4 suits: spades, clubs, diamonds, and hearts. That means each suit is 13 cards because they're 52 divided by 4 is 13. 2 suits are black, the spades and the clubs. 2 suits are red, the diamonds and hearts. So each of those is 26 because it's half the deck. Whoa. Thanks, board. Do what you want. Face cards are considered to be jacks, queens, and kings. So you have a jack, you have a queen, and you have a king that are face cards, and you have 4 suits. So 3 times 4 is 12. So there are 12 face cards. Now the only way you can guarantee getting kings is choosing from kings. Tens choosing from tens, spades choosing from spades, hearts choosing from hearts, face cards choosing from face cards, right? So they say I need this many face cards, you have to choose it from the face cards to guarantee getting a face card. So here it says poker is a card game played from a deck of 52 cards. How many different 5-card poker hands are possible? Now cards are always combinations, unless you have to like war. War you have to lay it in the order it is. But what's the first thing you do when you get the cards? When someone lays out 5 cards for you, what do? You pick them up and you do what with them? Arrange them to whatever arrangement is best for that card game. If it's hearts, you put them in suits. If it's Uno, you put them in colors, right? Like you pick them up and you move them. So did the order matter? The 5 that they were handed to you, did you have to play them in the exact same 5 pattern that was laid out for you? No. So cards are combinations because the order in which they hand them to you doesn't matter because you can play them put them in your hand and you move them around, right? So they're combinations. So here it says, how many different 5-card poker hands? Well, I know it's a combination, so I have to use a C. I know I'm picking 5 cards from how many? Does it say it have to be this many hearts, this many spades, this many face cards? No. So how many do I get to choose from? 52. So there are 2,598,960 different poker hands. 5 cards that could come up that would look totally different. That's how many there are. 2,598,960. Like a king of spades, king of clubs, king of hearts, king of diamonds, and an ace of diamonds, right? If we had to order them, then it would have to come up in that specific order. That would give you an immense amount more. So here it says, how many hands will there be if they're all diamonds? So that means I need 5 diamonds. How can I guarantee getting diamonds? Choosing from the diamonds. So I'm going to choose 5 from how many? 13. So now there are only 1,287 different hands that would look different with all diamonds. The next one says 4 blacks and 1 red. So how can I guarantee getting 4 blacks and 1 red?
Off the black cards.
Black cards, choose from, so I'm going to choose 4 from the black cards, and means I'm going to multiply, choose 1 from the red cards. How many black cards are there?
26.
26, half the deck. How many red cards are there?
26.
Now I need 3 kings and 2 queens. So I need to choose 3 kings, and I need to choose 2 queens. How many kings are there to choose from? 4, 1 in each suit. How many queens are there to choose from? 1 in each suit. So there's only 24 hands that can come out like this. These ones are the tricks. That's why they're at the bottom. I need 3 kings. That means exactly 3 kings. So people will say the answer is 4C3. And they give me that as the answer. How many cards need to be in my hand? 5. I currently have. What am I missing? I need to choose 2 more, right? That's what we're going to have to figure it out from. So what I'm going to do